Hey everyone, it's Jeff Downing again, Principal Engineer at Bright House Networks. I promised you that we would do some other slide decks. I'm going to run through a quick one now on Apache Jackrabbit. I'm probably only going to be able to get a third way through the slide deck. I think there's 72 slides in here, plus there was actually breaks in here to actually do labs once we get to it. But I'm just going to kind of skip over those sections. I'm hoping to get you at least to Mixins before we have to stop. So we already talked about what a JCR is, right? So it's a content-based repository. Yeah, there's two specifications out for it, JSR 170 and 283, and it's open source. Look those up, read them. I promise you, you won't be disappointed. That API is really easy to understand. The writer was actually decent. So what's a content-based repository? It's a hierarchal content store. You can read the definition if you want, but it's a way to store data more like a file, or not really data, but a way to store content more like a file system than a database, right? It makes it easier for users who aren't very technologically savvy to understand storage structures. So there's the argument that it's a database. It isn't, right? So a JCR uses a database to store things. A database doesn't use a database to store things unless it's itself. If a database used a different database to store things, it would just be weird, right? So a JCR enforces an API. DB doesn't really enforce one. They have other query languages and other APIs that are written by other people, and they adopt them, but it's not really enforcement. SQL Server doesn't enforce you to talk to it at the kernel layer. Right, the API does, the JCR does. JCR is built on a set of standards. A database can utilize a lot of different standards, but the implementations vary and they're never in agreement over it, right? So the Java community has PL SQL, everyone else has SQL. They all deviate somewhere. JCR is a single standard that all content repositories are built upon, even though the argument's probably there that there's only two. All right, a JCR stores content, database stores data. We won't get into that argument, but basically I told you on the last slide that data is stuff you can aggregate, min, max, sum, store long-term, do calculations on. Content's just crap that goes on a website, right? It's stuff that users want to tweak. It's paragraphs, marketing copy, images, right? So what's JSR 170? That's a specification for a content repository API. So what's 283? Version 2.0 of the same API. Yeah, it was a trick, right? You still need to read them both, but you could pretty much start with 283 and get a gist of how it all works. So what's hierarchical data look like? Well, right? First thing you say when you think of hierarchical data, a developer thinks of, oh yeah, the file explorer. Yeah. I don't have a Windows machine, so here's a picture of a Mac one, right? The one on the top right is actually the $1 million one that you're paying for. It's built into CQ, and the one on the bottom is the free one that's built into Sling. Yikes, right? But you see how everything's stored in hierarchies and nodes? Right? That's the gist of it, right? That's how simple it really is on the outside. It's a good picture of what the overall architecture of Jackrabbit looks like. And these are the four things you really need to know, right? Repositories, workspaces, nodes, and properties. This is going to diverge into some other things, but if you know these four things, everything else is cake. So what's a repository? Well, some will say, oh, well, that's a database. No, the repository is the running instance of the entire JCR, right? If you want to think of databases, think of workspaces that way, just be careful. Repository is the whole system, okay? That which implements the JSR. That was, I don't know what I was on when I wrote that one. Apache Jackrabbit is a repository. CRX is a repository. There is a .NET one. Don't download it. You'll be really disappointed. Inside repositories or workspaces, there can be more than one. However, they all start with at least one called default, which is the one we are in about 100% of the time. I don't know anyone here that's ever created another workspace. I did it once. It was painful, and it threw some exceptions because I couldn't figure out how to work with it well. And I realized then that when creating workspaces, it is an administrative thing, and it has to be set up well ahead of time, and it has to be thought out, because you're not just going to be able to be in code and start hopping nodes across workspaces easily. A workspace always starts with a root node. Well, duh, right? So, and that root node is a single slash. It doesn't have a name, right? Everything else has to trickle down from underneath it, right? The name of the default workspace is default, and be careful and whatever, right? So you get the idea, right? So workspace is a collection of nodes, every single one of them starting from a root node. Anything interesting in that picture? No. All right. What are nodes? Nodes are the actual items inside of a hierarchy tree, right? And this is where thinking starts to diverge a lot from people that try to first compare this to file system. They're like, oh, so you can have folders and you can have files. No, those are just nodes. Folders a node, files a node. That thing underneath files a node. The folder underneath folders a node, right? Nodes are just things. Every workspace starts with a root node, and every node can have exactly one child. That means every child can have exactly one parent, right? Every single node can have, well, let me take that back. Node doesn't have to have a child, but a child absolutely has to have a parent, right? Nodes can have 0 more nodes underneath them. Nodes can also have 0 more properties underneath them. Doesn't have to have any properties, which would be weird, but it can also have an infinite number of them, in theory. If you have enough disk space, it could. And all nodes have a name. Now, the name of a node seems important, right? When you're dealing with in CQ, you're like, oh yeah, I have to go to content / news / article / article _1. Well, article _1 is very arbitrary. Sling made that crap up when it stored it because you didn't give it one. The name's not really that important, is it? You can say, give me everything underneath articles and be just as good without ever needing to know that single article's name, or you could just query for it. So the names are arbitrary. They're not like IDs like you would think of in a relational database, though we do have those. We probably won't talk about it in the slide deck, though. Every node has exactly one primary type, right? So, and you've seen the types before, right? You've seen like NT file, NT folder, but you've also noticed that there's a sling folder. And you're like, well, wait a minute. If they're both called folder, how is this working? Well, the answer is namespaces. It's just like XML. Sling : is just a prefix namespace, which you can't actually see the registration of it. It's actually in a different file, which we'll do in one of the tutorials. But what you're essentially looking at is a namespace declaration there that was prefixed with sling. So sling : folder is actually prefixed to an actual URI namespace, and that's how it stays separate from NT. But every node has exactly one type. That type could be unstructured, meaning I don't know what I am, right? It's probably safest that we use unstructured in many places, because that's more like a MongoDB storage document. It has no rules. It doesn't have any mandatory fields or any mandatory behaviors at all. It could do whatever, right? And speaking of behaviors, nodes get their behaviors by implementing mixins, which you can implement as many mixins as you want. Some examples are like versionable, observable, referenceable. Yeah. By the way, if you apply the mixin referenceable to a node, all of a sudden it gets an ID field that's auto-updated, right? So you start to get a little hint, hint, nudge, nudge, wink, wink there, right? A view into how it all works. And we're just going to go over the simple view, though, in this video. You can make your own node types. There are reasons to do it. There are more likely 99 reasons not to. And yeah, there's an API for that. Be careful with schema. Unless you're absolutely sure you want to ensure that this content always looks this way and behaves this way, just be careful. If you look at CQ, it's really important that a page always behaves a certain way, that a folder always behaves a certain way. But is it really that important that what's on the screen is always the same thing? Not usually. That's why it's stored in unstructured data types. Oh, by the way, this the node type that's being used is, you guys see it all the time, is a property called primary type. I don't know if you guys are familiar with that, right? Properties. They belong to exactly one node. Properties can't have child properties. I know it looks that way sometimes when you're in JSON, but believe me, they cannot. Those are actually nodes that you're looking at and not other properties. Properties can't have properties. Values store the actual content that's being stored in the JCR. I don't really know what I was trying to write there. I think I was tired. Can't be ordered, right? All right, so properties don't exist in a node in any specific order. And if you think about it, why would that matter? If you're in a node called article and you say, give me headline, why do you care if it was 3 down or 4 down? It doesn't really matter. The people that get hung up on this are usually getting hung up on SQL as always having some form of default ordering, right? Whether it be by ID or index or something. You can throw that idea out of your head. You're going to have to figure out how you want to get this stuff, because if you say, give me all children under articles, there's no guarantee they're going to be in order either, right? They're going to be in the order they were created. Always, right? So there's no default sorting mechanism for nodes. There definitely wouldn't be one for properties. MongoDB, you'll see this a lot too in document storage. Doesn't matter where the properties are, it just matters that they're in there. If you say find me something that has this property and it doesn't have it, or it's in a different place, it doesn't matter. It'll still either find it or tell you it's not there. All it hurts is us looking at it, which is not necessarily a reason to make it do that. Right? And the last thing is there's no such thing as null. If you put null on a property, it'll just remove it. And it gets that from XML. And if you try to make an element null, it just won't write it. Right? It's not there. There are 6 normal data types. Yes, there are data types for properties. I know the dialog XML makes it look like everything's a string. That's not true. If you deal with the API, there are 6: string, binary, date, which is ISO 8601, just like JSON, long, double, and Boolean. Yeah, by the way, notice no int. Right, long int is the standard. That kind of reminds you of JSON in a weird way, doesn't it? All right, so there's also 3 special ones. Name, okay, used to represent a node name. The only reason it has to be a special type is it needs to be aware of namespaces, right? Things that you put in front of the name. Path, path is always available on every single node. If you ask, hey, I got a node, what's your path? It gives you the absolute path back to how to get to it. And reference. If you ask for a reference, it's going to give you the ID of another node, which you can navigate directly to. It'll be a reference to another node. That one programmatically behaves different. You could ask and say, give me the reference ID, and that's fine. You can set the reference ID, that's fine, or you can just say, give me the node, and it'll hop all the way across the node tree and give you that node like you're now there. So be careful with references, and we'll get into them in later advanced topics in the tutorials, but they're really cool. Namespaces. You've seen them already, prefixed with a single colon. They're exactly like XML. They're declared the same way as XML. They're used for the same reason as XML, so I won't cover them. But there are some reserved namespaces. You can't use JCR, NT, Mix, XML, and empty. I would also suggest you avoid CQ, Sling, and anything else that you see in the pull downs in Adobe CQ, because those are obviously third-party implementations. Any item can be found by its absolute path. I already told you the root node's a single slash. Doesn't have a name, starts with slash. Slash is the root node, so if you start with slash, it's assuming you're starting from root at all times. If I say slash content slash news, that's root content news. That's the order it goes. Most people are used to that because that's the way file systems work. As a matter of fact, relative pathing works just like Unix file systems. So // means go back one directory before you start. Single // means from this directory that you're in. You can go // and go backwards relative to 3. Just be careful with those, okay? Someone will move your component one day and everything will break, and you'll try to figure out why. This will be why. Mixins, I told you add behavior. Some examples of these behavior are referenceable, versionable, orderable, lockable, shareable. None of those are actually words, I think. It's fun writing this because the spell checker just goes off referenceable. Right? But these all do different things, okay? So applying these to a node causes them to do different things. Let me see. I'm going to go ahead and stop it there because I'm pretty sure we're about close to the 15 minutes and we're about to get into some stuff here in a minute that's just way too far. So we'll pick this up from where we left off with Mixins, and I'll talk a little bit more about it.